Recording started.
Okay, welcome to the July 8th edition of the Manhattan GMAT Study Hall. Back to your regularly scheduled programming, so to speak, after a little bit of substitute instruction in the previous session. For those of you who just walked in, again, I have not seen the recording of the substitute session yet. I understand that it was a little bit more general and broad and a little bit less in-depth, which is cool. It's good to get a little bit of that, just to give you a sense of perspective on the whole verbal section. It's kind of nice contrast. But welcome back to the regular study halls. Today's agenda is mostly quant. We're going to start out with the usual reminders because I don't know how much overlap there is between the people who are present right now and the people who submitted the questions. But in this week's stock of submissions, we had a few questions that were totally not the kind of question that we can address in the study hall. So we're just going to review that as usual, as we normally do at the start of these sessions. And then after we do that, we're going to look at some things regarding sequence notation and some considerations regarding percents. And both of these items are over and above what is in the 9-session course, although they do touch on some of the materials in the strategy guides, but it's, as usual, enrichment material. So let's go ahead and get started. These are the usual warnings. In case they look fuzzy on the screen, that is the way the graphic looks. Your screen is not being weird. So for some reason, the resolution on this slide did not come out as well as it usually does. But let's just go over this again really quickly, because some people, again, I don't know if those submitters are here right now, but some people are still submitting questions that are pretty clearly not conforming to these guidelines. And in most cases, when they're doing that, they're submitting questions that we just can't answer. The biggest one, the biggest offender here, so to speak, is people asking questions that are just way too general for a study hall. For instance, one of the submissions in the past week, like one of the submitted questions for this particular study hall was, do you have any strategies for answering the critical reasoning problems? That was the question. I think that was word for word. I mean, that's so much stuff. There's no way that you could do that in a study hall. I mean, the most you could possibly do in a study hall would be one type of critical reasoning problem. For example, we spent a whole hour and a half on boldface questions a couple of months ago, and we spent a whole hour and a half on finding assumptions. So, guys, if you submit a question that's like, what are the strategies for critical reasoning, or, you know, how do I do geometry? Too general. It's not the kind of thing we can do in a study hall. I mean, there's a reason why our books on those topics are hundreds of pages long. You know, you can't boil them down to a single session's worth of material, nor would it make sense to really try to do that. Also, you don't want to be too specific. You don't want to submit a single problem and submit a question that's like, what's the difference between these two answer choices? Those kinds of questions, those belong on our forum. Those kinds of very specific questions are the entire purpose of the forum. So remember that this is a study hall where we have about 40 to 50 people watching the study hall, and then we also have several hundred people who watch the recording. So questions that are this particular are usually not that relevant to an audience this large. So if you just have a question about a couple of answer choices on one problem, then you should submit those on the forum instead of here. Especially considering that the sources that are allowed on the forum are precisely the same sources that are allowed here. So anything that would be banned on the forum will be banned here, and vice versa. So please, if the questions are this specific, submit them on the forum. And then also, not too personal, I'll be brief with this one because I don't think anybody did this past week, but remember, this is not the place to submit things that are like, here's my current GMAT score, and here's my goal score, and what's a study plan for me. There's a folder in the forum called the general folder, general questions. That is actually the folder in which we answer things most quickly. When things are posted there, we generally answer them within 2 to 3 days. And that is the folder in which you would want to post things like that. And if it's an admissions question, if it's specifically about B-school admissions, then we have a folder for that too. We have an Ask an Admissions Counselor folder. So there you go. Smiley face, if you guys understand these guidelines, please. Smiley face icon. Again, the smiley face icon is over there on the left. Okay. Especially the not too general. We've still got a lot of people submitting things like, how do I do critical reasoning? Which, there's hundreds of pages on that. Okay, also sources, guys, if you submit a specific problem, you've got to tell us where it is from, even if it is one of our problems. Because remember that your submissions just show up as basically email messages. So we don't have the problems memorized. We don't really know what problem comes from where. I mean, occasionally I'll see a problem and know where it's from. But we don't have a photographic catalog of all of our problems, and so if you submit a problem that doesn't have a source listed, then we can't use it because we don't know where it's from. So even if the problem is one of ours, if you could just briefly cite where you got the problem from, that would be great. In particular, this week, I think almost all of the specific problems that were submitted did not have sources listed. They were just problems. Here's a question, here's a bunch of answer choices, which, however much we would love to answer those, if you don't tell us where the problem is from, we cannot answer it. So, sources, you got to tell us where they're from. Also, banned sources, you can't use the OG, that's a big one. A couple people submitted OG questions. We are not allowed to do OG questions on this study hall. We do OG questions in class because everybody in our classes, by definition, has paid for the official guide. So that gives us permission to use their problems. Fair use, not a copyright violation. On the other hand, these study halls are free. They are no obligation. We have no idea who owns the OG and who doesn't. Therefore, we cannot use OG questions. Same reason we can't use them on the forum, because it would be equivalent to giving away copyrighted paid material for free. You can use GMAT Prep, because GMAT Prep is free. So if a question appears on the GMAT Prep software, I'll go ahead and type this on the board. You can use problems from the GMAT Prep software, which is a free download. And then in case you guys are wondering if there are problems that overlap between the GMAT Prep software and the OG, then you can also use those. So anything that is in the free software you can use. And when you do quote a source, please do not quote another forum as the source. So if you got a problem from GMAT Club or Beat the GMAT, please do not submit it unless you know where it is actually from, because these places are not original sources of problems. These places don't write problems. They just contain problems that other forum posters have gotten from elsewhere. Okay, smiley face, if you are okay with these little rules and regulations here. These three are just what is reasonable and what is not. Things like this we can't answer even if we wanted to. Things like this are better on the forums, and things like this are irrelevant to our audience. And this is nuts and bolts. This is a regulation that it's copyright. I mean, we would love to discuss OG problems here. We really would, but we can't. Okay, so let's get into the meat of the material. In particular, let's talk about this. Sequences and sequence notation. Okay, let's talk about what this means. Does anybody want to type in the text box any sort of interpretation in words of what this means when you see something like this? What is going on here? If you want to type in the text box. Yeah, I think you guys can all see what each other is typing, and I like the summaries that are being typed here, especially the stuff that's being typed by Dan and Dee Dee in terms of the next number and the previous number, the relationship between a term and the immediate next term. So let's talk about this. If you see a sequence definition that only contains n as a subscript, does anybody give me the non-smiley face if you don't know what a subscript is? There's anybody out there who doesn't know what that means, a subscript. Okay, a subscript is these little numbers here. Like x is not a subscript, x is a regular script, a regular variable, but these little numbers here on the bottom are called subscripts. So let me just indicate that here. All right. So that's what subscripts mean. These are subscripts. They don't have to be n plus 1 or n. I mean, a subscript can also just be a number. But the point is that a subscript is this kind of text where it's it's smaller and below the level of the regular text. If you see a sequence definition that only contains n in subscripts, then ideally you should not be thinking about these as substitutions. Like I'm seeing a couple people writing substituting in values to get sequence. Actually, it's more like what these posters, Dan and Dee Dee, are saying, where you think of it in terms of next and last. Right? For instance, so let me write this out. If you see the variable only in a subscript, you should try not to think about plugging into the subscripts, unless you literally can't think of anything else. Unless it's absolutely necessary. Instead, think in terms of current value and next value, or current value and previous value, etc. So here's an example. Let's say you have the following salary scale. Example. Let's say that you have a factory worker's salary scale where in the first year this factory worker makes $40,000. And in the second year the worker makes $43,000. In the third year the worker makes $46,000. And then et cetera, every year it's $3,000 more. Okay. There's two ways to describe this sequence. The first of which is to give a formula for it explicitly in terms of n. So we'll talk about that. Algebraically, this might be easier to think about, but in terms of common sense and real-life interpretations, this is not easier to think about. So one way to do this is to use an explicit formula. If you write something like A sub n equals, I have to type subscripts. There's going to be some delays when I type subscripts here. I apologize for that, but there's no way to type subscripts in line while I'm typing other things. The explicit formula for this sequence would be A sub n equals 37,000 plus 3,000 n. Okay, for instance, if you plug in n equals 1, then you get 40,000, as you should. You plug n equals 2, you get 43,000, etc. Okay, smiley face if you understand how this formula gives this sort of sequence. Okay, now the problem, there's a plus and a minus here. All right, the upside of this is that this is very easy to understand from the standpoint of pure algebra. All right, the downside of this, the downside of approaching this as an explicit formula, is that it's totally disconnected from real-world thinking. Disconnected from real-world thinking. Because no one is going to describe, I mean, no one, if you ask someone how to describe the salary scale, no one is going to describe the scale as like 37,000 plus 3,000 times the number of years you've been working there. I mean, no one in the real world is going to describe this salary scale this way. It's just not going to happen. So that's the downside here. So segue from this, how would people describe this in the real world? Go ahead and type in the text box. Like how, in words, how would people actually describe this salary scale? Because they certainly wouldn't describe it with anything approximating this formula. Okay, a couple of you are typing. I'll go ahead and wait until you guys type. So the poster who wrote 52,000 minus 3,000 n, no, you can't do that because if you plug in, you have to have a formula where if you plug in 1, you have to get 40,000. If you plug in 2, you have to get 43,000, and so on. So this is the only equation that'll work like this because it's a linear equation. You can't have two different linear equations for the same line. If you have, in fact, if you have 52,000 minus 3,000 n, that would go down every year, which would be a little bit of a depressing salary scale. Okay, yeah, let's talk about how this would be described in the real world, which is, you guys are giving me some pretty good descriptions here, so let's go there. The way that people would describe this would be what you guys are mostly saying there in the text box, which is two things. First, you would say you make 40,000 in the first year. And then each year's salary is 3,000 more than the previous year's salary. To say more as with an E. Each year's salary is $3,000 more than the previous year's salary. I mean, this is how people would describe this in the real world. And notice what this translates into is this translates into one of these types of recursive equations. In particular, in the first year, what would we call that? Yeah, well, this is what, when it says etc., that's what that means. It means this pattern continues. So, I mean, in the GMAT, they would be a little bit more specific about that. Like they would guarantee you that the increase is constant for each following year. That's what I mean to imply by etc. here. So I hope that clears that up. Okay. What do we call this if it's the first year's salary in this type of notation? What equals 40,000? That's what people are typing. Yeah, we call it x sub 1. That's what the subscript notation means. So we call this x sub 1. Again, I apologize for the time delay in typing subscripts here. X sub 1 is 40,000. So that's how that works. That's not a recursive description yet, but it will be with the next statement. So X sub 1 is $40,000. And then here's the kicker. Each year's salary, so this is going to be X sub n. Each year's salary is designated as X sub n. So that's an arbitrary salary. Yeah, it takes me longer than it should to type the subscript. X sub n. 3,000 more than is exactly what it looks like. It's going to be a plus 3,000 on the end of the equation. And then, so there's an equals there. And then plus 3,000. And then who knows how you would write the previous year's salary if you want to type that in the text box. Yeah, it's X n minus 1. It's good. So X sub n minus 1. Okay. There you go. Now the point here is that a lot of people would look at this equation and they would interpret this. Yes, you can, which we'll write in a second. A lot of people would think of this in terms of literally plugging in n's. And you don't want to do that because that just takes so much time. So the goal here is actually for you to go the other way. The goal here is that if you see something like this, then if you see something like that, the idea is that you would take that and you would think in terms of this rather than in terms of substitution of literal variables. You think like this. That's the idea. It's very powerful. This is if you only see the variable in the subscript. Okay, we're going to deal with sequences in a little bit where you might see the variable outside the subscript. If that happens, then you're going to have to break down and do a substitution. And as someone else has adeptly pointed out, let me, oh yeah, no, don't worry, we'll have questions for you. As somebody else has nicely pointed out, we got to drag all these guys down here. It'll take just a second. Another way that you could write this is you could do this instead. Instead of making that n minus 1, you could make that n, and you could make this n plus 1. Because in each of these cases, notice that you don't, I mean, these are both the same sort of thing. Like if this is X sub n and X sub n minus 1, this is still the salary for whatever year, and this is still the salary for the year before that. Same thing if it's n plus 1 and n, there's really no difference. As long as this is 1 more than that, it's the same relationship. So n plus 1 is the year after year n. Similarly, year n is the year after year n minus 1. So actually, both of these statements mean exactly the same thing. As for the question, how do we know the starting point is 40,000? You have to be told that. I mean, notice that you need both of these facts to describe this sequence adequately. If I just told you this, then you would know that the starting salary was, you would know the salary went up every year by $3,000. But that's all you would know. You would not know any actual values. You would just know how much it went up by. So yeah, you're correct. You have to be told this. Notice that has profound consequences for data sufficiency, because if you have this formula, this is all you need. If you have this formula, then you can just plug in and you can figure out exactly everything. But if you have this formula, this is not good enough by itself. If you have this is the increment. This is how to get to the next year's salary from this year's salary. But if you don't have some sort of starting point, then that's not good enough. So, well, it's not just an increment value. Like in this case, it's just an increment. But let's go ahead and put this in words. Let's do it for this one that's over here. It's this lonely formula over here. It's been hanging out for a while. So in this formula, I have to give you a value for something here. So let's say we've got x sub 1 equals 4. Okay. Somebody summarize what this means in words. This. What does this mean in words? So you can use words like the next term and the current term, or the current and previous terms, anything like that. See if you guys can summarize this in words. Yeah, I like Devin. I don't know if you guys can see, smiley face if you guys can see what is in the text box. I'll wait till a couple of you type more things. Yeah, I'm liking what I'm seeing here. Give me the smiley face icon if you guys can see what's in the text box, like what each other is typing. Okay, so you guys can see that. All right. Yeah, like we don't want to think about this as a formula involving substitution because it's too time consuming. Like if you are just ridiculously fast at algebra, then that's one thing. But what this means in words, this means that the next term, to find the next term, you double the current term, then you add 3. And notice that you don't need any substitutions or anything to figure this stuff out. You just have to realize that this is phrased in terms of next and current. So in particular, this is the next term, this is the one you're trying to find. This is whatever the current term is. Then you have to double that and you add 3. So notice how much faster this will make computations. So if you have x sub 1, let's do this. I need to type subscripts separately. So let's get all the subscripts in there before we start the discussion here. X sub 1. X sub 2, X sub 3, X sub 4, X sub 5. Notice that you don't have to plug in for n to do any of this. You just have to realize that you're doubling whatever you have and you are adding 3. So X sub 1 is handed to you. That's 4. Again, when you have these are called recursive definitions. When you have definitions like this, you must have a term handed to you. It's impossible to figure out anything with a formula like this unless you have at least one hard value. So, okay, what is x sub 2? Go ahead and type the text box. It's 11. Yeah. So it is 3, 2 times 4 plus 3, which is 11. Then you just take 11 and do that. That's 22 plus 3. Then you would take 25 and do that. By the way, I'm known for making frequent errors in arithmetic, so if you guys do notice me making any arithmetic errors, then please do not be shy in pointing them out. Thanks. Okay, this is 106 plus 3. Notice if you had to plug in for n, this would be a way more time-consuming task than it has to be. Okay, notice this does not require plugging in n. to actually plug in for n to figure this out. You just need the idea of next and previous. Okay. Smiley face if this stuff makes sense to you guys. These are called recursive sequences. They like them. They are big fans. Okay, I see a couple of you are typing questions. So before we move on to some problems, see what you guys have in the way of questions. I'll wait till you guys finish typing. The question is, do we usually get this sort of thing, or do we get this? Well, I mean, you'll get both. It's not really a matter of usually. It's a matter of both of them could very easily show up and very likely will, and so you should be familiar with both of them. There's no prioritizing to do here. You should, you can do both. So, but explicit formulas, these are everybody's favorite algebra equation. So people are familiar with these already. These are generally not too much of an issue for people, because these are the kinds of formulas that you've been using since beginning algebra class. But most people are not as used to doing this, which is why we're covering it today. Okay, I see a couple more people are typing. I'll see what you have to type. But in general, they're not real big on textbook things like geometric progression, because they're not big on things that favor people who are heavy on textbook learning. So if you have memorized a bunch of formulas for geometric progressions, the chance that you will actually get to use those is very close to zero. It's not actually zero, but it's quite close. So, because the whole point of this test is to not advantage people who have memorized lots and lots and lots of formulas from school. Okay, let's take a look at some questions. So here are two data sufficiency problems. The first one is missing a couple of subscripts. Let's do something about that. My subscripts around where? Okay. This is A1, A2. And then this is supposed to say A10. Okay. I'll give you a timer with 4 minutes on it to try these two. Well, let me cover up the second one for the moment, because we can only do polling for one at a time. So I'm going to give you your A through E multiple choices. We are assuming that you know how data sufficiency works. If you don't know how the data sufficiency answer choices work, then please try to follow along as best you can. But this is a traditional data sufficiency style problem. I'll give you about 1:45 to go ahead and try this. Here's the timer. Please indicate your answers in the polling box. Do not type them in the text box. Thank you. So again, there are, please answer the question with the A through E buttons. And I've just adjusted the polling so that you cannot see each other's answers. Okay, guys, in the next 10 seconds, please try to indicate an answer to the data sufficiency problem. There I see about, not in the text box. Please observe what has been written up here. Please answer the question with the options at your left. You should be seeing an A, B, C, D, E options. at the left here. Please go ahead and click on those. Thank you. There's an RB, a Partha, and a Min who still haven't answered the question yet. And a J Morkheim and a Dinesh. Okay, 5 more seconds. Okay, here are the polling statistics. So you guys did overwhelmingly get this correct, but let's go ahead and discuss. I noticed what I noticed in this problem was there was a definite bifurcation between people who finished the problem in the first 30 seconds and people who took the full time. That's an interesting fact, and we'll be able to explain this shortly. The interesting fact is everyone who answered in the first 20 to 30 seconds was correct. The wrong answers were mostly given at the end of the time period. And here's why. Because if you think about this problem the most efficient way, then it really doesn't take you very long to figure it out. So how should I think about this problem? Well, the key is how to conceptualize this formula that's up here. Remember what we said on the previous slide. On the previous slide, we noted that if you see an xn plus 1 and an xn, that means the given term and the previous term. So let's go ahead and just explicitly notate that here. Down here in the lower right. This is like the next term, and this is the most recent term. And that's how you do it. You just take the most recent term and you add 3,000. And the key to this problem is thinking about this the same way. If you conceptualize the formula as an plus 1 is the next term, that's the term that we're trying to find, 3 times the most recent term, so the previous term. Let's call it current term is 3 times the previous term, plus 2. That's what this formula means. Smiley face if you guys understand that. Other face if you don't. Okay, I'm seeing a lot of smileys and I'm not seeing the other face. Okay, that's good. So what this means, for example, is like if I've got the 7th term, then I can find the 8th term doing this. And I got the 8th term, then I got the 9th term doing this. Yeah, etc. So for instance, like if I have the first term, I can use this to find the second term. If I have the 55th term, I can use this to find the 56th term. So, any case where you have anything. So, what is the value of a sub 10 is just a really obnoxious way of saying what is the 10th term of the sequence. So with statement 1, I've got the 7th term. So I don't have to actually calculate anything. I mean, again, this is the key. We've mentioned this in a couple of other study halls, but this is the attitude you got to have with data sufficiency. I have the 7th term. Therefore, I can use it to find the 8th term. Then I can use that to find the 9th term. Then I can use that to find the 10th term. So that's sufficient. And I mean, notice that there is absolutely no need for me to calculate anything. And if you do calculate stuff in this problem, that is what swallows up all this time that you don't have to swallow up. Because it's data sufficiency. Remember, you guys have got to learn to think about data sufficiency with an absolute minimalist approach to calculating stuff. The point of, I mean, this is a recursive sequence. The way they want you to understand this is if you have a term, then you have all of the terms that come after it, because you can just keep repeating this. So, yeah, no, if they give you one of the terms, then you're good with this kind of thing. So, smiley face if this makes sense. Okay, and if you guys are grinding the formula and actually calculating the terms, just make sure that you understand why that is not an efficient use of your time. Okay, now, notice this formula lets you work forward. This formula lets you work from the previous term to the current term. But notice you can solve this formula. So, if you solve for previous term, you can subtract 2 and then divide by 3. Current minus 2 over 3 equals previous. And so you can also go backwards. All right, this is important. If you can, because like this approach that's right here, this lets you move forward through the sequence. But this formula lets you move backward through the sequence. Not all sequences will let you solve like this, but in this case, if you just move the 2 and move the 3 over, you can work backwards. So like if I have the 55th term, I can use this to find the 54th term. So I can work backwards through the sequence as well. Smiley face if that makes sense. Okay, looking for the smile, I'm seeing the smiley faces, that's good. So now we can look at statement 2. And you shouldn't, if you calculate the actual value of A10, you should get 26 both times. Again, I'm not the world's best at doing arithmetic, but you should get 26 both ways. But remember, if you are even bothering to calculate these things, then you are not thinking about data sufficiency the right way. Like the thought of, it is the same. You should get 26 out of both statements. But again, you should not be calculating this stuff. If you do, then you are not approaching data sufficiency with the right mentality, and you're going to throw away a lot of time on the test. But if you do the calculations, you should wind up with, unless I made a mistake, which is very possible. I think I did make a mistake. No, I don't think I did. Maybe. But the point is that you can calculate the values. You shouldn't actually do it, though. Here I have the 14th term. If I use the green method of working backwards, I can work backward to the 13th term, then the 12th term, then the 11th term, then the 10th term. Sufficient. And again, you should not be bothering to calculate this stuff. any questions about this? Again, if you do, unless I made this problem up today, so if you, it is possible that I made an arithmetic error in the problem statement. I certainly wouldn't say that's impossible. But if you shouldn't be calculating these values. Any questions about the conceptual aspect of what is at work here? As for the question of are these related to functions, I mean, yeah, these are functions. I mean, a sequence is technically a function that you can only plug whole numbers into. It's different from most functions in the sense that most functions let you plug in any number you want, whereas you can't plug in decimal numbers into these things. Like there's no such thing as a 3.5 term. But again, you shouldn't think of them the way you normally think of functions, because these kinds of recursive sequences you don't want to plug into. And if you actually plug into these, that'll waste a lot of your time. One other person doesn't have negative numbers well, the reason that this is specified is that you don't like sequences to have like a -4th term. So this n greater than or equal to 1 is just preventing us from having like a 0th term or like a -5th term. Because otherwise you could just work backwards like this until you got a negative number terms, which would just be ugly. It'd still work in theory, but it's just not pretty. Okay, smiley face if you guys are ready to move on to another problem. Okay, all right, let's do it. This one is more difficult than the preceding one. Okay, I'm going to clear out your answers. Again, please do not answer the question in the text box. Thank you very much. Here's the second question. And again, there's your instructions. Please answer the questions with the A through E options. I will warn you ahead of time, this is a hard problem. But I'll also give you a little clue here, which is that if you have to guess, keep in mind, like from prior study halls, if you've seen them, keep in mind the sorts of things that the test uses as sucker answers to trick people into guessing incorrectly. Okay, I'll give you, there are two people who have already answered the question, and those two people are wrong. Okay, I'll give you, in fact, those two people both picked the sucker answer that I'm trying to tell you about here. So here's a timer. Go for it. If you are one of the people who has already picked an answer, you do not have the right answer. I made up the problem. Okay, because this problem is extra delicious, I will give you another 20 to 30 seconds or so to work on it. So, but by the time that timer runs out, everybody pick an answer, please. Thank you. Okay, there are a few people who do not have answers. Go ahead and guess if you don't have one. Again, this problem is really, really hard. In fact, I made up this problem earlier today. In all honesty, this problem it's probably at the 800 level, if not even a little bit harder than what you might see. So if you're having difficulty with it, then it's entirely understandable. Okay, a couple people, Garima, Matthew, Partha, Raj, go ahead and give guesses, please. Guesses. Okay, let's call time. Here are your statistics. And interestingly enough here, I mean, we've got, this just shows that people are basically guessing because there's an almost even distribution of answers here. But interestingly enough, the correct answer to this problem is A. So, it's a tough problem. But A is the correct answer. So let's take a look. Does anybody know what the sucker answer is to this question? The answer that they want to try to get you to guess. And what is sucker-ish about that answer? So yeah, the sucker answer is C. Does anybody know why that's the sucker answer? Yeah, you guys are nailing it. And I mean, again, I know we touched on this in previous study halls, but you guys have really got to learn to think the way the test thinks. Because I kind of knew this would happen, but there were several of you who put C within like 15 seconds of seeing this problem. And a couple of you, it was like 5 seconds. Right? I threw the problem up there, boom, C. This is not how they work. They do not give you problems that are involved with recursive sequences, but then you can just randomly do linear algebra. It's not like that. Like if the problem involves recursive sequences, you are darn well going to have to understand recursive sequences to figure this stuff out. So in any case, the sucker answer is C. Because they want you to think. They want you to think. You can't start from a 10 because you don't have a 10. We'll get there in a second. They want you to think, hey, I can solve for A by subtraction. And then substitute and find A7. And so then you'll have, I mean, this would give, if you do this, you'll have, you can find it. I mean, we give you A7 is 4, A is 3. But, and then, yes, you can do this. And first, let's have a side note here. It's actually not a side note. It's actually the crux of the problem. What does this actually mean? Can anybody summarize this in words? Words? Anybody? Stephanie, nicely done. I'll wait for a couple of you to answer. There's a lot of text in the box. Yeah. It's the sum of the two previous terms, right? The equation says, given equation means that you can find any term by summing the two previous terms. Yes, this is like the Fibonacci sequence. If you guys are interested in this is not the Fibonacci sequence because you're not given 1 and 1 as the first two numbers, but if you're interested, this has a name that you can Google. It's called the Fibonacci sequence, spelled like, it's an Italian name, so it's a little bit hard to spell. But if you want to Google that on the internet, then you can look that up using the name Fibonacci sequence. Okay, but going back to what this means, I mean, the sucker answer is just saying, oh, I have the two numbers. It's going to be more than just that. But notice, okay, therefore, there's two things that you should, if you have to guess, you should be suspicious of C, because this is just too easy. especially if you know that you are a high-level quant score. Because remember, the test is adaptive. So if you are generally high-level in quant and you see this problem, you should be looking here and saying, there's no way that I can just solve the system. They're trying to sucker me. If you are generally a lower level scorer in quant, it's not that automatic, because if you're more towards the bottom of the quant scale, then there may be a problem where you just have to solve the system. But if you are a higher level quant scorer, which a lot of people in these study halls are, then make sure you are aware that almost never will you just solve a system. Okay, but also note that E is impossible, because after all, these two statements are sufficient. So you have all the numbers, right? I mean, like if you have to guess, you should notice that if you do have these two statements, then you have A7 and A8, so you have everything. So therefore, you at least know that E is wrong. Because E would mean, and a couple people guess, in fact 5 people guessed E, so make sure you 5 are paying attention. Because you do have, I mean, E would mean that even with both of these statements, you would still not be able to solve this, and that's wrong. If you have both of these statements, then you can find everything. All right. Let me tell you how this works. Statement 1. Basically what you do is A7 is just A7, but then you can solve for A8 in terms of A7. Because remember, 2 variables is bad, 1 variable is nice. That's also a topic we've touched on in previous study halls. Let's see. That was on the December 17th edition of the study hall. So let me just give you that quick reference there. That December 17th study hall, try to minimize the number of variables. So in this case, A7 and A8 are still variables. So we don't want both of these. So if we have that, we can solve that. So if we do, we get A8 is, you move A7 over and you subtract by, and you divide by 2. So that's 5 minus A7 over 2. Smiley face if you see where this comes from. You subtract A7, and then you divide both sides by 2. Smiley face if that makes sense. Smiley face. I'm not seeing a lot of smiley faces. Okay, that's better. Alright, so we can solve for A8. So that's 5 minus 1/2 of A7. Then you can just add these. You can sum the previous 2 terms. So if we do that, then we can find A9. So that's A7 plus that whole expression. And so that gives you A7 over 2 plus 5. And then if you want to find the 10th term, you just do it again. So that you add the 8th term and the 9th term. So, and then you have expressions for those. So the 8th term, that's supposed to say A9, not A0. The 8th term is 5 minus 1/2 A7. And then the 9th term is 1/2 A7 plus 5. And you get cancellation. Life is a beautiful thing. These go away. And so a sub 10 is 10, and the statement is sufficient. What's interesting about this is you don't know a7, a8, or a9. But a10 is magically determined. It's very cool. So, I mean, part of the reason I think it's very cool is because I wrote the problem. But this is definitely how data sufficiency works. NISA in the text box is pointing out a very clever way of doing this. But that's very clever. That's not, you would have to have a very sort of clever and creative instinct to figure that out. That's a beautiful way to solve the problem. But writing 2a8 as a8 plus a8 is a flash of insight that most people are not going to have. How did I get a8? I solved. I just did algebra on this equation. I isolated this variable. So I isolated this variable up here. So I just subtracted a7 over the other side, and then I divided by 2. I did algebra. Does that make sense? Okay, a couple other people are typing stuff. All right. Well, you can't calculate per se because you don't have any hard values. Like, notice that you don't have numbers here. Because it turns out we don't know what a7 and a8 are. We'll get there. There's a plug-in method that you can use. Yeah, 5 is half of 10. So when you divide by 2, you get 10 over 2 is 5. If you do this with statement 2, we won't do it here to conserve time, but try doing the same thing. You'll wind up with variables in your expression for a10. Therefore, that's insufficient. Whereas this is sufficient. Crazy stuff. A couple of you guys are also coming up with very cool substitutions. You can check that out. The text box here is a wealth of information, and I think what you guys are all saying is all legit. Okay. What I want to show you here is another way of doing this, which is a plug-in method. I know we've talked about plug-in methods in other classes here, but I want to show you the power of these plug-in methods. So I got to do a little bit of jockeying here. Part of the delay, guys. All right, so here's the problem again. And I'm also going to copy the explanation that we have in words. Let's move that upstairs. You can also investigate this problem very quickly and much more easily by using plug-in methods. Let's talk about how that works. Okay, here's how plugging in works on data sufficiency. The way it works is like this. You have to plug in multiple possibilities that satisfy the statement. And then the way it works is if you ever get 2 different answers to the question, then you're done and it's insufficient. And if you always get the same answer to the question every time, then you should pick, you basically just give up and you pick sufficient. So let's try this. Let's do this on statement 1. You basically just have to pick pick a few different pairs of A7 and A8 that satisfy the equation. Okay, who can give me a few of those pairs? Just give me an A7 and A8 that do this. Hard numbers. Okay, I hear 3 and 4. Actually, it would be 4 and 3, not 3 and 4. But yeah. Okay, so let's try that. A7 could be 4 and A8 could be 3. Or you could have 0 and 5. You could have 10 and 0. Let's try all of these. A7 is. Somebody said 8 and 1. That works. Somebody said 10 and 0. Somebody said 0 and 5. And then just for kicks, let's try negatives. Nothing wrong with negatives. So let's try 20 and -5. I mean 18 and -4. Okay, this is 5 possibilities. If I get the same result 5 different times, I'm going to be pretty darn well convinced that this is sufficient. So let's try this and see what it does. Remember, you just sum the previous 2 terms. So A9 is 4 plus 3, and A10 is 3 plus 7. Okay, it's 10. Okay. A9 here is 8 plus 1, and A10 is 1 plus 9. A9 here is 10, and A10 is 0 plus 10. Here, A9 is 5. And A10 is 10. Here, A9 is 14. And A10 is -4 plus 14, which is 10. Okay, I am pretty darn well convinced. Yeah, you have to, I mean, yes. You have to satisfy this. This is not a condition. I mean, this is how you find the numbers in the sequence. I mean, this is not something that you are picking. This is a rule that you are using to find the subsequent term. You're not picking things. But if there were conditions in this prompt, then yes, you would definitely have to obey those. Okay. Carlo, I'm not sure what the question is. I mean, right now we're just investigating statement 1. So right now we don't care about statement 2. But this is okay, I'm pretty convinced. It's 10 every single time. So I'm convinced. So I'm going to pick sufficient. Alright, smiley face if you guys understand this. Notice how awesome this is. I mean, all you have to be able to do is add numbers together. I mean, it's certainly a lot better than having to wrangle with all that algebra on the previous page. I mean, like literally, if you guys can add numbers, you can do this. It's very cool. You just have to have the flexibility to be willing to try these plug-in methods. If you try statement 2, let's pick up a few more numbers. Pick some A7s and A8s that satisfy A7 plus A8 is 7. So let's try a couple. You might do, A7 equals 5 and A8 is 2. Or you might do A7 is like 6 and A8 is 1. If you do these, okay, here A9 is 7 and A10 is 2 plus 7. Here A9 is 7, and A10 is unfortunately 1 plus 7. You're done. We do not need to try any more numbers because it's done. It's insufficient. If you ever get two different answers, done. Insufficient. So the answer is A. Notice, yeah, that's the other reason I like this problem. The problem is absolutely obnoxious. Like using algebra, this is a really hard problem. But if you guys know how this plugging method works, it becomes nothing more than like adding a bunch of single-digit numbers together, which is my idea of fun. It's very cool. Any questions before we move on? You cannot assume any number. You have to pick numbers that actually do this. So like if you're doing statement 1, you have to make this true. And if you're doing statement 2, you have to make that true. You can't pick anything in the world. For example, if you pick 1 and 2 for A7 and A8, then these become lies. Then they're not true. Like you have to actually make the conditions true. So, but otherwise you can pick any numbers that make the condition true, which is what I think you're trying to say. Okay. How about that? All right. Now, let's look at a different kind of sequence problem. A couple of you are typing things. Do I know of post about the best way to pick numbers? Yeah, I know it is hard. I acknowledge that moving to plug-in methods is very hard, and I've always acknowledged that whenever we've discussed it. But as you can see, it's worth it. It's something that often works and is often very easy on problems that are otherwise really hard. So, I mean, the hard part is not using the plug-in method. The hard part is quitting the algebra when you are not getting anywhere. Because it's hard because you have to admit to yourself that you have to swallow the ego and you have to admit to yourself that you are not getting anywhere. That's the hard part. The hard part's not, I mean, the plug-in method is not that hard. I mean, you know, it's just you plug in numbers. But you have to quit what you're doing earlier, and that's the hard part. You can use fractions and decimals. I mean, if this is not convincing you that it's sufficient, then you should probably be convinced a little bit more easily than you are. But if you really, really, really feel like it, then yeah, you can throw fractions in there. It'll still work. I mean, you can use, I don't know, 6.2 and 1.9 for its A7 and A8. It'll still work. I mean, you can go ahead and try it at home. Statement 2 is not contradicting statement 1. There is a set of values that is in common, which is 4 and 3, but you don't have to have all of the same numbers. The stem says this is n though. This is not the A7 and A8. This means the numbers in the subscripts. The reason why the subscript is at least 3 is because otherwise this statement doesn't work. Like the smallest n is A3, which would mean the third term is the first term plus the second term. If you tried to let n be 1, then that would say A1 is A0 plus a negative 1, which doesn't work. Well, we don't number terms with negative numbers. But this absolutely does not mean the terms have to be at least 3. That's not what this means. This means the subscripts do. Not the actual terms. The terms can be things like these. Okay. Let's look at something else. Okay. Let's go ahead and discuss this. This is the only problem we have in this department. There's some percent stuff if we have time. Go ahead and try this. I'll clear out your answers. This is not a recursive sequence, so the stuff about previous and next does not apply to this problem. But go ahead and try this. Here's a timer. I'll give you about 1:45. This is not data sufficiency. This is a normal multiple choice. Okay, let's try to get answers in the next 20 or 25 seconds for this thing. Oh, yeah, a subscript somehow got lost in the shuffle here. This is supposed to say A sub n, so if that's missing, thank you. I'll give you guys another minute and change because maybe you didn't understand this. So A sub n, this is supposed to be A sub n. So why don't you take another minute or so on that. Okay, let's get answers to this thing, please. Please pick an answer if you have not. And next 5 seconds or so. All right. So here's the statistics. Here's how this works. I'll give you the quick rundown because the timing is starting to run a little bit short here. But if you see a sequence in which the n is actually in the terms, like not just subscripts, then if the n is actually in the terms, then what that means is that you have to actually plug in the n. So in this case, you actually have to plug in n to find the terms. Okay, so what this means is that what is the A sub? What is the A sub 1? What's the first term? Yeah, it's 3. Okay, so let's get a chart going. Let's get a list going here. Okay, so A sub 1 is 3 over 1. A sub 2 is 4 over 2, 5 over 3, 6 over 4, 7 over 5, 8 over 6, etc. So the product we want is this. So the first terms are 3 over 1, 4 over 2, 5 over 3, 6 over 4, etc. But then it ends with 12 over 10. And then the numerators, the denominators rather, are as follows. Okay, now the deal here is that you've got, oh, they could easily ask you to calculate the product of the first 50, and it wouldn't be any harder if they did. So we'll see why. What is the pattern here? The key fact here is this. If the GMAT ever asks you to do something with more than like 3 to 4 steps, then you will always be able to find a pattern. Okay, you should be able to find some sort of pattern that will shorten the work or will allow you to discover the answer without having to actually do all the steps. So what is happening here that shortens this calculation considerably? Can anybody type in the text box? Yeah, Carlos got it. And there's a great deal of cancellation. In particular, all of the top terms will cancel except for the last two. And all of the bottom terms will cancel except for the first two. So I'm going to type the 11 there just so we can cancel it as well. So the 11 is not going to go away, but the 9 will, because there's a 9 upstairs. Smiley face if you guys see how this cancellation works. Notice that what does not cancel out here is these and these. So that's all that's left. 11 times 12 on top, 1 times 2 on the bottom. And so that is 11 times 6, which is 66. So yeah, I mean, you should definitely be able to find patterns in cases like these. If you really don't see the pattern, then you should probably just start grinding. Probably just start grinding out the steps. But you should really look hard for the pattern. So in response to, well, this is not a data sufficiency problem, so these don't really have sucker answers. I mean, not all problems have sucker answers. But if a problem has a way that looks really obnoxiously simple, then, especially on data sufficiency. So in response to the person about the 50 terms, yeah, totally. Like if you needed the first, in fact, let's say that what's the product of the first 1,000 terms here? Who can type that in the text box? Product of the first 1,000 terms. Yeah, same thing's going to happen, right? You're still going to have the 3, 4, 5, 6, 7, all the way up to the only things that won't cancel are the last two, which if you go up to 1,000 terms, those are going to be 1,001 and 1,002. And then on the bottom, you're just going to be left with 1 times 2. So I noticed that finding the product of the first 1,000 terms is not really any more labor intensive than finding the product of the first 10 terms. I mean, obviously you couldn't grind this one out. You could not grind out 1,000 steps. I mean, because the GMAT people are actually weirdly nice to you. In a lot of problems like this, they will give you a number of terms that they want you to do this. They want you to use pattern. But at the same time, they will give you a number of terms that is small enough that you can still work it out by yourself if you have to grind out the terms. What they're doing is that they're giving you 2 opportunities. And in a lot of problems, they give you multiple opportunities. They give you a problem that, if you're going to grind this out, you better get started, basically. But it's few enough steps that you can legitimately do it without, using half an hour. So they're more likely to do this than they are to do that. But in general, the GMAT is not into busy work. So if you think you have to grind out the same step 10 times in a row, you don't have to. There will be some sort of shortcut, some sort of pattern that will allow you to circumvent having to do that. So FYI. Difficulty level here is not important. I mean, this is not a super high difficulty level problem, but it's not super low either. It's somewhere in the middle. But like, the point is this takeaway. I mean, this takeaway is still what you want to learn. And if you start boxing problems into high difficulty levels versus low versus medium, then you're not going to be learning. It doesn't matter how hard this problem is. It makes no difference. Because for your study, the only thing you care about is these kinds of lessons. And if you put problems in boxes according to difficulty, then you will probably not be getting the lessons that you need. So, okay. The question in the text box, I mean, the product is going to be some god-awful big number. They're definitely not going to ask you that. The first 1,000 even numbers all multiplied together, that would just be obnoxious. For the sum, you could just use normal sum formulas, like average times how many numbers there are. So, average. I mean, you can post that question on the forum. In fact, that's probably the best place for you to post that. So, go ahead and post that in the forum, and we'll give you a fuller answer than we can give you now. But the only reason I pointed out the difficulty level of this problem is because it's really obnoxious, and so if you were lost on this problem when you first did it, the point of me pointing this out was to basically say, look, it's okay if you are so confused that you want to cry here. But on other problems, you shouldn't be concerned with difficulty level, because the more you worry about difficulty level, the less you're going to learn the things you actually have to learn. Because this lesson here is independent of how hard the problem is. And there are problems that are both easier and harder than this one where you use this same idea. So don't worry too much about difficulty levels. All it's going to do is sidetrack your studies. Okay, so we still didn't get to percents. We had a lot of love with the sequences today. That took us our whole session. So what we'll probably do is punt the percentages over to the next study hall, which is July 22, and I think it's 7:30 Eastern Time. And we're going to close this session pretty soon here. So, if you have brief questions, you can go ahead and type them in the text box. Otherwise, the text box says, can you do a session on critical reasoning? I mean, again, that's much too general of a thing to say. If you're going to submit a critical reasoning topic, you've got to be more specific than that. So, okay, why don't you submit that? We already did a session on assumptions. Let me tell you when we did that. We did find the assumptions in the March 4th recording. So if you want to go to the home page and watch that recording, then that's pretty much all I have to say about finding the assumption. We've done a few modifiers. We did a lot of modifiers actually in the October 6th study hall, but I don't think they have a recording of that. Guys, please submit these things on the submission form. The submission form, I'll go ahead and put a link here. Here is the link. Submit topics at this website. The topics that you're submitting right now, I'm not going to see later. So the recordings are at the link that I just posted in the text box. So if you can see that link, that's where they are. That link also has there is a recording on permutations and combinations. That's December 3rd. That's December 3rd, 2009. The scheduling is we are rigidly back and forth between 7:30 Eastern and 7 or 7:30 Pacific. So the idea is that half the sessions are really late for people on the East Coast but are convenient for people on the West Coast, and the other half of the sessions are really early on the West Coast but convenient for the East Coast. So it is what it is. If you can't make the session, the idea is that you would watch the recording. Let's see. I don't think we have done anything on median and range. Some modifiers, we did a few modifiers on October 6th, although I'm not sure that, there may not be a recording for this day.